Okay, let's go ahead and get started with electricity. This is our last unit. Electricity and magnetism is our last unit in physical science, so I know you're eager to go ahead and get it finished. Now, first thing we're going to talk about is electric charge. Electric charge is an electrical property of matter that creates electric and magnetic forces and interactions. And what happens is it uses the electric and magnetic forces to create those interactions. And an object can have a negative charge, a positive charge, or no charge at all, which y'all should already know and be familiar with. Now, electric charge, another thing about electric charge is that like charges repel one another and opposite charges attract. And we learned this when we first learned about protons and electrons, and remembering that opposites always attract. Now, electric charge depends on an imbalance of protons and electrons. So if you have more electrons than you have protons, you're going to have something negatively charged. If you have more protons than electrons, you're going to have something positively charged. And the pictures below help demonstrate that like charges repel and opposite charges attract. Now, electric charge can also be transferred. Now, transfer of electric charge is when different materials are rubbed together. Electrons can be transferred from one material to the other. For instance, if you look at the picture on the left, you have a glass rod and a piece of silk. They're both neutral charges right now, but once you rub them together, they create a charge because electrons were transferred. Now, another way to think about transferring electric charge is also static electricity. Static electricity, this is how static electricity is transferred. And we'll talk about this in a little bit more detail. But first, let's talk about the things that can transfer electric charge. Conductors. Conductors allow charges to flow, so it allows electric charges to be transferred. Insulators do not allow charges to flow, electric charges to flow. So that means that when you have an electrical conductor, that electric charge can move freely. When you have an electrical insulator, electric charge cannot move freely. Now, an example is the picture down below showing you a wire. This is a typical wire that you would find on an appliance in your house, like going from your TV to an outlet, from your hairdryer to an outlet, the wire that goes with your Christmas tree lights. And on the inside, they have an electrical conductor, which is copper wiring, because metals are the conductors. And electric charges can flow freely. Well, as electric charge flows freely, it becomes hot. The longer it flows, the hotter it will get. And so the wire has an insulator or a piece of plastic, some kind of insulating material on the outside covering the copper wiring so that you don't burn your hand when you're unplugging it. Also, so that if the cord is laying on the carpet, that it doesn't heat up enough where it can cause the carpet to catch on fire. This is also a lot of times why we hear of Christmas tree fires, because part of the insulating material might be rubbed off or gone, and so the wire is exposed, which touches the Christmas tree branch or the bristles on the tree, and then it allows a fire to start. And so it's very important to make sure that your insulating material is all intact before lighting your Christmas tree. Now, let's talk about the ways that this electric charge can be transferred. The first way we're going to talk about is that it can be charged by friction. This is when one material gains electrons and becomes negative, and the other loses electrons and becomes positive. This happens when you're getting in and out of a car. When you're getting in and out of the car, your clothes rub against the fabric of the car seat, and you're charging by friction. So one part is becoming negative, the other part is becoming positive. And that's one reason why you have static electricity when you get out of the car and touch the door. A lot of times you'll get shocked, and that's static electricity. And this is known as charging by friction, when two materials rub one another against one another and they charge one another. Now, the second way that you can transfer electric charge is by induction. Now, induction is when two things are not touching one another, but the electric fields are still in action, and so they can still actually move charges amongst uncharged objects. Let's look at the picture on the left. It has a charged rod, which has a positive. It's just full of positive charges. You have a piece of aluminum foil that originally was neutral. Now, what has happened, since it's close to the charged rod, the charged rod has pushed the positive charges to the opposite side of the piece of aluminum foil, and it has moved all of the negative charges to one side. So the negative charges are on one side, the positive charges are on the other side, and those are induced charges. They're not touching one another, but the electric field was strong enough to move those charges. Now the third way that you can transfer electric charge is by conduction. And this is an example of charging by contact. See the picture of the hand and the doorknob. The hand is positively charged mostly. The doorknob is negatively charged. When they touch one another, you're going to have that static electricity again, and it's a transfer of electric charge, and so electrons are going to be transferred. Now let's look at electric force. Electric force is the force of attraction or repulsion on a charged particle that is due to an electric field. And the electric field is the area around a charged particle or a charged object, okay? And electric force at the atomic or molecular level, you know, the level we can't see, is actually responsible for a lot of everyday forces that you observe on a day-to-day basis. Now these are all field lines, and we're going to talk about those in more detail in just a moment. Now, electric force depends on charge and it depends on distance. If you increase the charge, you increase the electric force strength. If you increase the distance, however, you decrease the electric force strength. An electric force acts through a field. That's what we've been talking about. And then I've already said that electric field is the area around a charged object. And you can come in contact with the electric field without actually touching the object and still experience the electric force. A lot of times you are shocked before you actually touch the door of your car, just because you've come in contact with the electric field of the door, right? So you can see the field lines drawn for an isolated positive charge and an isolated negative charge. And then one important thing to remember is that electric field lines never cross one another. Okay, they never cross one another. They're always going to, once they come close, they're going to bend like you see in this picture to stay away from one another. So this is what I'd like you to do. This finishes electric force, and I'd like you to summarize for me. I'd like you to write down the 3 ways electric charge is transferred, give me an example of each of those ways, and then also explain each one of those ways. Okay? I hope you have a great evening, and I'll see you in class.